Newton's law of motion. So we have done the basic stuff, very basic stuff. And now today we'll see each laws in detail. So Newton's laws of motion. We'll start with each law separately. So what is first law? We have discussed what is first law. Am I audible to you?
Yes.
What is the Newton's first law?
Inertia. An object at rest will stay at rest until an external force is applied on it.
Very good. So unless it is not applied, right? So it talks about the inertia, isn't it?
Yes.
So what you said is correct for me. Nothing wrong about it. Okay. I'll put this in literature as quickly as possible. So this is the law of nature. This is the law of nature. And you can say according to this law, a body at rest will tend to be at rest, correct?
Yes.
Or in uniform motion will continue to move with uniform motion unless acted upon by unbalanced external force. So this is also called law of inertia. Okay. But in kinematics, we have studied that rest and motion is what?
Can you repeat?
In the kinematics, we have studied that the rest or motion is basically a frame dependent idea, right? So a body can be at rest and the same body can be in motion depending on from which frame we are observing.
Yes.
So the Newton idea of rest and motion is somewhat difficult. So what is the actual Newton's idea of rest or motion? It is again frame dependent. No? So is it possible to actually observe something at rest in all frame,
No.
or it is at rest only in some frame?
In some frame.
Some frame. So that's the whole idea. We cannot have a body which will be at rest in every possible frame in the world. So the question is, if rest itself is not defined, then what is the meaning of rest in the Newton's idea? Okay. So somewhere we have to start believing that this is a frame which is at rest, or a frame which is moving with uniform velocity. Okay. So the problem is the validity of Newton's law is only for certain variety of frame, not in all frame. So whatever laws of motion you're going to study, it is not applicable for every frame. So Newton defined certain frame in which his idea was valid. Okay. And these frame we called, what we call? These frame we
Non-inertial.
call no inertial frame of reference. Inertial means the frame in which the Newton's laws of motion is valid. Okay. So you can say inertia, or you can say this law gives the definition of what? This is called the definition of
Inertial frame of
inertial frame of reference. Reference. Understood?
Yes.
So now we'll talk about something called what is inertial frame of reference. Inertial frame of reference. We'll talk about this in detail. What is inertial frame of reference? Okay, we'll talk about this in detail because that is the basis of Newton's laws of motion. So what we say is Newton's laws of motion is only applicable for inertial frame of reference. Now the question is if it is only applicable for the inertial frame of reference, and we know that the inertial frame means a frame which is either at rest or moving with constant velocity. But if something is at rest or moving with constant velocity, also depends on some other frame, right? So what exactly is inertial frame? So now here comes the problem. The inertial frame is assumption. We have to assume something, and the assumption depends on the kind of the analysis we are performing and how much it is suitable for the experiment being performed. So how much we can go along with such accuracy. Understood what I'm saying?
Yes.
Every frame is, see, inertial frame is a definition that a frame which is either at rest or moving with constant velocity is called inertial frame. But the problem is, who will say this that this frame is inertial? Because the person who is saying the frame is inertial is also a frame. So the Newton said that see, the inertial frame is assumption, and there was a frame that he assumed, and he make sure that okay, this is the inertial frame which you have to believe, and then every other frame which is inertial in that frame is also inertial frame. So we start with some assumption. Okay, so the assumption is simple. So Newton assumed, you know what he assumed? He assumed Earth. Why? Because see, our every experiment, research, analysis is being performed on Earth, right?
Yes.
And because everything is happening on Earth, we do know that today that okay, Earth is revolving around the sun. But for every purpose of research, experiment, and etc., it is a good assumption to start with Earth for every experiment which you perform on Earth. But one fine day, you start believing that Earth is not a good, frame of reference because you want to understand the motion of Earth itself in the cosmology, in the universe. The day you want to start studying about the Earth, then we need to switch the reference from the Earth to something else. So where we will go? We'll go to the sun. So for the motion pertaining to the planets in our solar system, we take sun as our next close inertial frame of reference. So the sun is a better choice, you can say. But let's say if you want to study about the entire solar system as a whole, then we need to talk about the nearest galaxy because sun is orbiting around a galaxy. Then we'll shift our we'll shift our assumption to the galaxy as our initial frame, and then we will discuss the motion. So there is a subsequent shift of the reference frame, which is suitable for the given purpose. So if you are doing something on Earth, then Earth is a good reference or good assumption, and any inaccuracy that will arise because of the Earth motion can be ignored in all those calculations, because eventually we have to live on Earth. So Newton assumed Earth as what? Inertial frame of reference, and other frame any other frame which is also any other frame which is either at rest or moving with a uniform velocity with respect to Earth will act as inertial frame of reference. So that is the whole idea of inertial frame of reference. It is only frame. So this entire topic of first law is applicable for a variety of things. We assume Earth has the inertial frame, and therefore anything which is inertial in the frame of Earth is also inertial in general. Okay. So the inertial frame remains same accordingly. All right.
Yes, sir.
So this is the inertial frame. First law gives you. So what is the purpose of first law? First law not only gives the idea of inertia, but first law is also a way to understand a frame of reference, which we now call the inertial frame of reference. And we need to be very careful that the laws of Newton we cannot write from any random frame. The laws of Newton we can only write either in the Earth frame or in frames which are inertial as seen by Earth frame. Understood what I'm saying? So you can say that every building on Earth is at rest with respect to Earth. Yes or no?
Yes.
The Earth itself is moving around the sun, so the buildings are also moving. Buildings are also rotating because Earth is turning about its own axis. But with respect to Earth, those buildings are at rest. So every building on the Earth is inertial frame of reference, isn't it?
Yes.
So anything which is either at rest or moving with uniform velocity in the Earth frame by default becomes inertial frame of reference, and the Newton's law, whichever law we are going to study, will be applicable in that frame. Other frame, the Newton's law is not directly applicable. We do make it applicable through some modification, and that is what you will learn in a topic called pseudo force. So pseudo force is a technique to make this possible, even in the non-inertial frame. How to write Newton's law when the frame is non-inertial? So there's a rule for it. So we'll come to that rule later on. Okay. So now we can go to the Newton's second law. What is second law? Second law is not a law, it's a definition, but it is called law. So up to, you can say, JEE level, it's okay to call it law, but it is not actually a law. So what the second law says? We have discussed the second law. Can you explain what is second law?
Rate of change of momentum.
Yeah, so go ahead and tell me completely. And try to recall. Don't try to see the definition. You may have a notes, but don't see it. Try to recall and try to explain. What is Newton's second law? Yeah, second.
Mm.
Tell me.
Then I'm only able to remember the rate
No,
of
dude. See. I mean, it's like you're not supposed to remember anything. You're supposed to create through your logic. So if you remember that what we have discussed in the last lecture, if you try to frame that into a sentence or language, it is going to be easy for you. Understood? It is not difficult. Don't say it's difficult. It is possible.
The momentum definition, right?
Yeah, like how Newton perceived the idea of force. And I have explained it's a reverse process. You know that momentum is changed by the force, but we are trying to understand the force meaning through the observation of momentum, isn't it?
Yes.
So think about it.
Momentum is the measure of inertia.
Momentum is the measurement of
Inertia.
inertia. Which inertia?
Motion.
Yeah, try see. Be more. You have to be more precise in defining things.
It is the measure of inertia of motion.
It is the measurement of
Inertia of motion.
inertia of
Motion.
inertia of
Motion.
moving bodies. See, inertia we define for bodies, right?
Yes.
Inertia of motion means inertia of moving bodies. Understood?
Yes.
So, yeah, go ahead.
Inertia, sorry, momentum is the measure of inertia of moving bodies.
Yeah, momentum is the measurement of inertia of moving bodies.
Hmm.
What is the measurement of inertia of bodies at rest? Tell me. What is the inertia of bodies at rest? Hmm?
Mm.
Tell me. What measures the inertia of those objects which are at rest? Am I audible?
Yes.
Yeah. Tell me.
Mass.
Mass. Very good. So mass is a measurement of
Inertia.
mass. Yeah. So mass measures the inertia of bodies at rest, but momentum measures the inertia of bodies which are in motion already. Okay.
Yes.
And what is the job of force? What force does? What is the definition of force? We defined the first lecture. What was the definition?
Force
Tell
is
me.
the physical cause
Mm-hmm.
when put on a body changes the state of the body, shape, size, and dimension of the body.
Quite good, quite good. So at least you're getting something. But if you try to understand the entire process, you're not, supposed to be, taking so much effort to answer it. Definitions should come naturally. Because if you really understand something, then definition will also become a natural process. Okay.
Yes.
So Newton's second law, what is Newton's second law? Who will tell? Sure, you can tell. Do you remember the Newton's second law? No. All right. So according to this law, according to this law, what we can say? The rate of change of momentum is directly proportional to, see, who will change the momentum? It is the force, because momentum of a body, sorry, momentum of a body cannot be changed on its own. We need someone who can change it, because momentum is representing the state of motion of a body, and therefore that cannot be changed without application of force. So the way we are saying is the reverse process. You are looking at the change of momentum and you're trying to infer the force or deduce the force or understand the possible magnitude of force. This is how you're trying to understand. So what Newton is defining is the reverse process. It's the effect versus cause. Looking at the effect, we're trying to judge the cause. So what is force? Cause or effect? Force is
Cause.
cause. So what is the momentum change? So momentum change is what?
Effect.
Definitely, it's the effect. So now you can answer, no? You got the idea. You know the momentum, you know the effect. So what you can say? The rate of change of momentum is directly proportional to applied
Force.
Force.
unbalanced external force. So now you will be surprised to know that what is external force. Sometimes we do have a very different kind of force, which is called the thrust force, which is generated from within. Okay. So if you have seen the rocket in the Diwali, when you burn the rocket, it goes up, right? So the burning fuel creates the internal force. So the fuel which is leaving the rocket will create a thrust, and the thrust is powerful enough to take the rocket against the gravitational attraction. So the idea of force is it must be external force. We are talking about the force which you apply externally. So this is the law. The rate of change of momentum is directly proportional to applied unbalanced external force. There are two things which will come to know. One is called external, other is called the thrust force, and other is called the net force. And these all three terminologies are quite different. We'll come to that definition. The thrust, external, and the net having slight variation. Sometimes the net force and the applied force are same, sometimes they are not same. So we also need to understand that what exactly is the meaning of these terminologies of calling external force or calling the net force or calling the thrust force. So this the rate of change of momentum is directly proportional to applied unbalanced external force and one more thing and what? And the direction of momentum change, and the direction of momentum change will be in the direction of applied force. Understood what I'm saying?
Yes.
So now tell me, what is the meaning of last line? I mean last sentence after and the direction.
When we apply a force, there will be change in the momentum of the object. It will be along the applied force. It will not be opposite of the force applied.
or any other direction.
Yes.
See, the momentum is not important. The change in momentum will be in the direction of applied force. So mathematically, we'll come to that. What is the meaning of this mathematically? So mathematically, what we can say? Mathematically, what we can say? The force, if I write by force by symbol Fext, and always remember we are studying vector, so force is a vector quantity, so we must define in vector form. So in high school, you might have used this, I mean, scalar notation, but now for JEE, one should write in vector form. So you write F vector, and it is proportional to the rate of change of momentum. So we write as dp by dt. When you write something in a differential form, then this represents the instantaneous value. Instant and therefore the F external will be equals to some constant into dp by dt. And I have told you that force cannot be measured in an absolute term. It is just a kind of an empirical relation. So this is the and with the help of this relation, you get the a comparative value of force. Understood what I'm saying?
Yes.
So in SI unit, because it's a matter of comfort, so in SI unit, we take k equals to 1, and therefore the force becomes how much?
dp by dt.
So this way of definition will give you the instantaneous force, the force at certain instant. And dp by dt will give you the change at that instant. Understood what I'm saying?
Yes.
Okay. So you can think this way. So we'll take two example, one in one dimension, then other in two dimension. So imagine there is a football or ball, whatever, which is moving with certain velocity. So let's say this force is F. Sorry. Let's say it's moving with velocity v. Mass is m. So what is the momentum of this object in the beginning? Momentum equals to mv. In one dimension, we don't put the arrow every time because it is like understood that if I am writing positive, I'm taking, let's say this direction is positive, then the left will be negative. So we can take care of direction with the help of plus or minus sign. The reason is in one dimension, the arrow is not required, but these are vector equation. Okay.
Yes.
Now you apply some force instantly. So at t equals to t, this is the velocity, and imagine you apply a force. So what will happen after some time t plus dt, because the time given is very small, this object this object will increase its velocity from v to v plus dv. because the change in the small time will be elementary change, right? So you can also say that the momentum will change by what? P plus dp. Understood what I'm saying?
Yes.
The momentum at t equals to t is p, but the time dt afterwards, the momentum becomes p plus dp. Understood?
Yes.
So what Newton is saying, that the force which you have applied at this instant is in one dimension. So force at this instant is the change of momentum upon change of time, but these changes are the elementary changes. So this is the instantaneous force. What we call this force? Instant. Now, sometimes it is difficult to find the instantaneous force because you have no idea about the exact variation of force, how it is changing over the time. So in such case, we define something called the average force. So we need to understand there is something called average force, which you can represent as, so, so average force means you do it for the interval instead of the elementary time, which means the calculation must happen over a large interval of time. So whenever we are trying to calculate the change for the large interval, let's say this is T1, let's say this is T2. So it's a big interval. And let's say the momentum here is P1 and momentum here is P2. So the average force that the object must have experienced over the duration. So we don't know what is the force, whether it is constant or variable or whatever. I have no idea, but I can say that the average of the force that this object will experience, we can write as the total change in momentum upon total time taken. So this you can write as delta P. So now you can see the delta P is the bigger change, a big change, and the time is when you define something over a large interval of time. If you try to find the change of that momentum over that interval, and if you divide by that time interval, what you get is the average value for the that duration. So this is called the average force. I hope this is clear. The average force meaning.
Yes.
Now, in a
Yes, sir.
one dimension question, what you need to realize that in one dimension, we don't change the direction, we only change the magnitude. Okay, because it is one dimension, so we are not changing the direction, we're changing the magnitude. And when you change only magnitude, then it is easy to find the average force, find the change of magnitude and of the momentum and divided by time. Okay, so this is also called the average force. Sometimes we need to find the average force when there is a collision process. So let's say there is an object, and this object is coming with some initial velocity v, and then it comes closer. It makes an impact to shrink like this, and then it will try to restore the shape. So it will try to zoom out again slowly. So it will come first and it will, I think we want to be able to see it. It will bounce back like this. Okay. And eventually it will leave the wall. So you can see that it has been contact with the wall for some interval, although very small, but there is an interval for which you remained in contact with the wall, and then you turn back with a new velocity v dash. This is the question in which, though the motion is one dimension, but there is a change of direction also. So how to write the change in momentum in one dimension? If the mass is m, you can choose this direction as positive x-axis. So you can write what is the p initial value? What is the initial momentum? Tell me.
MV.
So initial current is m into v, and we can write plus because it is in the positive direction. But how to write the final momentum? Minus mv dash y, because it's in the left side, right? So direction has reversed. Because the x is right, so positive is right. Okay. Okay, sorry guys. So now you can see the P initial is mv. How to write P final? Because the direction has changed or reversed, you must write this way. So what is the delta P? Rugved, tell me, what is delta P?
minus 2m v dash minus v.
Minus
2m.
why 2? Tell me, what is the meaning of change in momentum? How to find change of anything in the world? Change
Final
means
minus initial.
final minus initial. So what is final here?
Minus mv dash.
So whatever math says, just follow it. Minus.
mv dash minus v.
So why it is 2? Why you were saying 2? Any idea?
No, I added it accidentally.
In physics, as a beginner, when we start learning physics, the rule is simple. Follow the definition. Don't apply your own brain because it is highly immature and highly incorrect stage. So whatever you think or whatever the way you want to study or learn physics, that will not work. You have to follow someone who is more better, I mean accurate. So follow the rules which is already set forth for everyone. So you're not supposed to apply your brain. If applying it, it's dangerous. Delta P got how much? Minus m, v dash minus v, v dash plus v, right? Now, if we talk about the magnitude only, then we can ignore the modulus sign, minus sign. So we can simply say m into, correct? We can write like this.
Yes.
And because you can write like this, so let's say it was in contact with the wall for some time, delta t. Let's say delta t is this is called time of impact or duration of impact. That's a better way of saying. Duration of impact. So we can say the average force experienced by the wall, average force experienced by the wall due to wall is. So what is the average force you experience over the entire interval?
mv plus v dash by delta t.
Very good. So the average force modulus which you experience is delta p modulus upon delta t. So the answer is mv plus v dash upon delta t. Understood? And always remember it's the average value. So see, I mean, these are not required to be written this way. If you have understood that, this you can simply say the f average is this value. All right.
Yes.
So we'll do some practice to calculate the average force first and the instantaneous force. So let's do some practice examples. So let's say example 1. Someone is saying that in one dimension, motion of a particle, its momentum is given by. So in one dimension, motion of a particle is given by P equals to 5t square plus t cube minus 3t plus 6 kg meter per second. This is momentum. Find instantaneous force at t equals to 5 seconds. Also find average force for first 5 seconds. So there's a difference between the two statements. If you have realized, you can solve. So would you like to try this question, or shall I solve right away?
No, sir. 2 minutes.
So try this question and let me know the answer. Okay.
Done, sir.
Okay. So the first part.
123.
So the instantaneous process we have to do the dp by dt, right? So once you differentiate, what you get?
10 t minus.
plus 3t square minus 3, right?
Yes.
So if at a t equals to 5, so when time is 5, then the answer is 10 into 5. So 50 plus 120,
3.
3 or 2.
2. Yes.
So you got the same answer, no?
Ah.
So okay, the what is the average value?
47.
So we have to find the answer from final minus initial upon time. Time is how much? 5 seconds, right? So final means what is the momentum at t equals to 5? Initially is 0. So P5 means 5 into 5 square. And 0 means 6. So the average force turns out to be how much?
47.
125 plus 125, right?
Yes.
Minus 15 plus 6 minus 6. Anyway, so it is how much? 250 minus 15. Is this your answer?
Yes.
So what you realize that the instantaneous value is really high, but the average of that interval is low. It means it was very small in the beginning. It grew to the value 122, but the average for the entire interval came out to be only 47 Newton. Is this clear?
Yes.
So these are the one dimension question of momentum and force calculation. Okay. So if you know the momentum, you know the change, you can get the answer. From one dimension, the question that you will get is called the graphical problems. So there is something called force time graph, force, or, or you can say momentum time graph. That's better. Momentum time graph. So if I plot a graph between momentum and time, and let's say this is the graph passing through origin. So by definition of force, so what is force? So you can see the P is on the y-axis and T is on the x-axis, right?
Yes.
So this is basically dy by dx, isn't it?
Yes.
And dy by dx in mathematics we called slope of the graph, right? Isn't it?
Yes.
So you can say the force is nothing but the slope of the momentum time graph. So force is slope of momentum time graph. Is this clear?
Yes.
So if slope is constant, so can we say the force is also constant? So constant slope means constant force, isn't it? Tell me yes or no.
Yes.
So what is the meaning of graph under force time graph? So we'll come to that later on. But let's do one practice. So let's say I give you force and time graph. A very simple force graph I'll draw. For the given momentum time graph, for a given momentum time graph, plot force time graph. So they have given you this graph, then how the force versus time graph will look like? If you plot it here only. So can you try plotting the graph for the force and time? So if you know the momentum and time graph, how the force and time graph look like? Tell me.
The slope would be the force.
Correct. So you have to plot the slope. You're only supposed to do the nature of graph, not the exact graph or whatever. Just nature.
Sir, it would be constantly increasing, then constantly decreasing, right?
No, the slope is the force, right? So you can see the slope is constant. So it is not increasing. The momentum is increasing, but the force is not, right? So the force by definition is what? Only slope, no? So if you check the slope, is it fixed value? The line will have constant slope, yes or no?
Yes.
So slope is constant, so force is going to be same, no?
Yes.
And slope is positive, so force is a positive. So the graph will look like this:
Straight line.
constant, zero, because there is no slope, zero slope, right?
Hmm.
And now the slope is negative, isn't it?
Yes.
It will go downward. This is your graph. Understood?
Yes.
So you are supposed to also be master of plotting of graph. In JEE, the graphical skill is the one of the most you can say important skill that one must master over the years. So from today onwards, you can think that you have to always think in graphical manner. You need to interpret the graph. You need to interpret the slope. You need to interpret the area and the curve. So all these things we have taken care in mathematical tools, right? So I think you haven't watched the mathematical tools, yes or no? You came from kinematics, right? Rugved?
No, I was there for mathematical.
Yeah, you were there, no?
Huh.
So if you were there, then I think you should not feel difficulty here, right?
Yes.
So if you have forgotten things, then go and again revise. Spend some time. Okay. Okay.
Yes.
Okay. So let's move next. What you have seen was the one-dimensional question, but momentum, force, these are one dimension or two dimension. Tell me, these
Two.
are two dimension. So the way we define things, so force as a vector we define as the rate of change of momentum. But if we are talking about the change in the vector form, need not to be in one dimension. It could be in two dimension as well. Okay. So imagine we can define something. The dp we can write as what? F dt. So change in momentum we can write as force multiplied with time. And that is the whole idea, that when a force acts over a duration of time, it changes the momentum. What we call, when a force acts for a duration of time, it changes the momentum. Understood?
Yes.
So if you integrate both sides, then the left side becomes delta p, and the right side we can replace by a symbol which we call j, where the symbol j is called by definition impulse, and the impulse is defined as product of force and time interval. Understood? Impulse is a product of force and
Time.
time interval, or the time for which it is acting on the body. So you can think this way, that whenever a force is exerted on a body for certain duration, then the product is called impulse, and it is the factor which brings about the change in momentum. So this is called J equals to delta P, and this J equals to delta P is called in physics impulse momentum theorem, which is again consequence of Newton's second law. So we have derived from here, right? And this you can rewrite in general as J equals to P final minus P initial, right? That's the definition.
Yes.
So you can also write P initial plus J is P final, right? If you remember the vector chapter, resultant of two vector A and B, how we write? A plus B equals to R, correct?
Yes.
So this is the initial vector. This is the impulse which you receive, and as a result, this changes to the new value PF. So this is exactly following the triangle law, isn't it?
Yes.
Do you realize this is following the triangle law?
Yes.
So in a game of football, let's say there is a football. Imagine there's a football. So if this is a football and it is moving in this direction, then the initial direction will decide the initial momentum. Am I right?
Yes.
And then what you do next is you kick this football, but you're kicking the football in this direction. This is the kick. The kick, you can call the kick in physics as impulse. Because when you kick something, you kick means you apply force for certain duration, and the duration is so small that you don't realize that was a duration involved as well. So you kick the football, there is an initial momentum, there is a kick. Now these are two vectors. Which two vectors? This and this. Do you realize this?
Yes.
If you know the triangle law, can you tell me how the direction of PF will look like?
From
So
J
what is the triangle law?
from J to P.
From
Tail of J to head of P.
tail of J to the head of P, I, or vice versa, right? Depending upon how you choose the first vector. Which one is the first vector here for you?
J.
So what is the real event? You have a moving football, then you have kicked. So kick is the second event, na?
Yes.
So first you got the football, then you hit, isn't it?
Yes. Yes.
So the initial momentum is already there before you made the impact, correct?
Yes.
So you draw the PI first, then draw the J vector, and then the tail of the PI to the head of the J will give you the PF, isn't it?
Yes.
The first vector is PI, the second vector is J vector. So the PF will be tail of the first, tip of the second. All right.
Yes.
So if you do so, what will get? Tell me.
PF.
No, draw it. You will get PF. So how to draw? Try drawing it, then I'll draw. You can compare later on. So first you try, then I'll draw again. Do it. Very good. So that's the right answer. So the P initial is this way. From the tip of the first vector, you draw the second vector, J vector. And therefore, the direction of PF tail to the tip this is the PF, which means a football going right, if it is kicked upward, or you can say up means like this direction, the football will eventually start moving in this direction. So it was moving this way, but because the kick will turn the direction of football by some value theta. Understood?
Yes.
Okay. Hmm. So this is the direction. Now you can also find that because dimensionally everything is same, so this is momentum, force and time we are having the same dimension. It's kg meter per second. So we can also find the modulus of PF. So because these two vectors will have some angle, let's say let me make it a general answer. So if you know the initial momentum, if you know the impulse, this will be your final momentum, right? The triangle law, correct?
Yes.
And if this angle is theta, the angle between the PI and J vector, then you can say the PF equals to. So the modulus of resultant is how much? So we have formula for the resultant of two vectors. What is the formula for resultant of two vectors? Tell me.
PI is a modulus of PI square plus modulus of J square plus 2 PI J cos theta.
Very good. So that is our formula. So given the answer of PI and J, you can definitely find the PF value. Or vice versa, given the PI and PF, you can find the J also, isn't it? So
Yes.
PI plus J is PF. If I call this angle as alpha, so J is how much? PF minus PI, correct? isn't it?
Yes.
So J is PF minus PI, and therefore the mod of J will be how much? What is the formula for the difference of two vectors? Pi square plus Pf square
No.
minus 2 Pi Pf cos alpha. Why? Because the angle between them is alpha, right? So when we take the difference, then the answer becomes minus 2 cos alpha, right?
Yes.
And are you getting it? Why am we are getting this answer?
Yes.
All right. And because the other reason is you can draw it. How to draw these two graphs? So this we can rewrite as PF plus minus Pi. So J equals to resultant of this and minus of the first vector. If this is Pi, if this is J, if this is P final, if this is alpha, so the minus Pi will be how? How to do minus Pi? Reverse the vector. This is minus Pi. So the resultant of the two vector, the PF and Pi will be between this angle, right?
Yes.
So for any two vectors, the answer is going to be somewhere here. And to get the answer, you can complete the parallelogram like this. And then this is the J vector. I mean, of course, this is the graph. Uh, just a moment. Okay. Anyway, just a minute, it should be better. That's do it better. Yeah. So if you make the parallelogram, it look like this, and therefore, and of course, the J vector must be same whether you draw it here or here, all are same. And I will make it dotted line because this is not actual line. Is this clear?
Yes.
All right. Is this clear? Okay. Now the thing is, what kind of question we are going to get? Okay. So vector form is one way, but in many question, you won't be comfortable in doing things in vector form. So sometimes we use the component method. Okay. So we resolve the vectors and we get the answer accordingly. So I'll give you some practice how to solve question of two-dimensional momentum problem. So let's say we have a graph y and x, and imagine the p graph one momentum is like this. Okay, and the value of this momentum is, let's say, p, and there is one more momentum vector like this. Okay, this is also p in value. So if you want to combine this, what is the net momentum? So let's call this is the p initial. Let's say this is p final, which is numerically equals to p only. So how to add the delta p here? So final minus initial, right? By definition. But now you can say final is how much? E j cap. Do you realize that final is P j cap?
Yes.
What is initial?
P I cap.
So basically the delta P here turns out to be j cap minus I cap. J cap minus I cap. So if you want to take the modulus under root of, because j cap and I cap will give you how much? 1 square plus 1 square, which is root 2p. Okay. I hope this is clear.
Yes.
Let's do some more practice. Just practice. I mean, just you need to learn this basic stuff, how to write and all. So imagine we have a initial momentum here. And imagine we have the final momentum here. And then numerically it is same. And that's the theta is find delta P. Tell me the delta P value quickly.
Root 5 by 2p.
Yeah, let me check it out. So delta P we can write as P final minus. So final we can write as P cos 60 I cap sin 60 j cap P I cap, right? This is what you got. Hmm? So mod of delta P will be how much? Under root of 1 by 2 whole square. I mean, we can take P by 2 common. So it's 1 plus 3. Okay. So the answer turns out to be how much? And 1 by 2 we can take 1 minus 8, 3, 1, 2, 3, 4. This is understood.
Yes.
So the answer is P only. And how much you got and why you got? Tell me.
I didn't take the sin 60 j cap.
Why? Every vector will have 2 components.
Yes.
Like we should convert into 2 mutually perpendicular components, right?
Yes.
Because the perpendicular component will recreate the actual vector. Okay. So whenever you resolve into 2 components which are mutually perpendicular. You don't resolve only in one direction. Correct?
Yes.
All right. So let's say we have a circular track and there is a collar. You know, collar. It's a metallic cylinder with 4 space inside. And because it's like a collar, we call it collar. It can slide inside the ring. Okay. Now imagine this collar is moving with constant speed because it's a smooth surface in a horizontal plane. And this has been given a velocity v, and it turns from here to here. So we have done all this in kinematics, but still I don't know how much you remember. The speed is constant, so this is still v. So if this is t equals to t and this is t equals to, this is, let's say t equals to 0, this is t. Find delta p modulus and also find average force experienced by collar. In interval t. So take mass of collar as m. Take mass of collar as m. Okay. Is this clear?
Yes.
All right. Done. So you can keep on solving. Meanwhile, you can do the next question. Okay, I'll add the next question. A body of mass 5 kg under the action of constant force F is given by Fx So first part is done. Rugved.
No, sir.
Now again, if you see, then that's the problem. See, if you go back and think of kinematics, every such question we are already solved there. So there we used to find the delta V. Now if someone is asking you find delta P, how to write delta P? M delta V, that's it. If P is MV, so delta P will be M delta V because M is constant here, correct?
Yes.
Mass is not changing. So finding this is same as finding this, and this we know already. And if you don't remember, it means again the kinematics you haven't taken seriously. So you're doing the same mistake. If you're not taking kinematics seriously, the subsequent chapter will have the the huge application of the same. And that's why I have said, okay, see, we have learned kinematics for such a long time so that you can get the time enough to absorb the concept and practice enough to get the confidence. If you're still not confident about the chapter, then it's a really bad situation for me actually. My entire investment of time on you to strengthen your kinematics has gone. So ask yourself why you are not able to solve this question. What is the problem? Are you not getting the idea how to write, how to do what in a circle? We have done this question, circular question many times. If you go back from vector till this kinematics, you will see I have been using this circular question again and again and again, isn't it?
minus 3 I cap plus 4 j cap.
How much?
Minus 3 I cap plus 4 j cap.
For which part?
Second,
Second part. Okay. So the force F. So how much you getting the force? A body of 5 kg under the action of constant force. Force is constant. Has a velocity t0 this much and at t seconds. So what is the p initial here? Tell me p initial vector form. What is p initial?
10 into 6 I minus 2 j.
How much into 10?
5 5.
5 into. So what is p final?
5 into 6.
So 30 I cap minus 10 j cap. So what is delta p vector?
Minus 10 j cap.
30j minus 30i minus 10j.
10 j cap.
Huh? How much is the answer? 30j minus 30i plus 10j. Outright?
40 j minus 30 I.
So you got delta p. By definition, delta p is defined as force into time. Isn't it? So force vector into time is how much? 10
10.
seconds. And delta p got how much? 40j minus 30i. So F is how much? 4j minus 3i. So minus 3i cap plus 4. I hope this is clear.
Yes.
Any doubt in this?
No.
No, sir.
Okay. So now, okay, this was given 6j. We got the delta p, and then you simply divide by the. So just a minute. 39, initially. All right, fine. But what about the first question? So the first question, the delta v modulus, we got the answer is 2v sine theta by 2, and you can go back and check the notes, revise, and try to understand on your own. I'm not going to explain the same thing again and again. If you have tried, not understood, then I'll explain. So delta v we write modulus as 2v sine theta by 2. Theta is the angle turned, and therefore the delta p we can write as the modulus as 2mv sine theta by 2. Just multiply with m, and the delta t is defined as if I call the radius as r, so it is theta r is equal to the arc length upon speed, and therefore the average force will be how much? So the modulus of average force will be delta p by delta t. So your answer is 2mv sine theta by 2 theta r by v. Okay.
Yes.
So your answer will be the average force that this collar will experience is mv square by r into sine theta by 2 by theta by 2. This is the answer. Understood?
Yes.
So are you getting the idea how to solve the question?
Yes.
Okay. But now we'll go back to the Newton's second law again. But before that, one more question. So generally, when you throw an object, let's say if you have played with the ball and you throw towards a wall, it comes back, right?
Yes.
So let's say you throw at some angle, it comes at some other angle, quite possible. So find delta P, only value. So let's say mass is. So find delta P means find P final. So write each vector in vector form I cap j cap accordingly and try to get the answer. Do it, everyone. It is hitting with a speed u, but it is going with a speed v. So we can call this as impact problem. Do it quickly. Done, Rugved?
No.
Do it quickly.
We have to find delta P. Sir, I'm getting it in I cap and J cap.
Yeah, you must get in ICAP and JCAP. What is P initial first of all?
M into V cos 5 I cap.
Initial, beta, initial. You're coming here. This is the initial. This is final.
M U cos theta I cap plus U sin theta J cap.
Hmm. Are you sure?
Yes.
You know how to resolve vector.
Yes.
So the U vector is like this.
Hmm.
If you draw the origin at the tail of the vector, and if you draw the x and y axis, which quadrant you will get?
4.
And the angle it is making with which direction? Y axis or x axis?
X.
Hmm. How you see? With your eye, with your brain? How this angle is? Theta is given with x axis or with y axis?
Y axis.
So the theta is here, like this is you. Now tell me what is the P initial? I hope you can now do this. And for the final velocity, it's
U cos theta
because
J cap minus U cos theta.
minus,
U cos theta J cap.
that is the velocity. Now, what is the momentum part? Momentum is minus
M into
into,
U cos theta J cap.
and that's it only. That is one component. What is the other component?
U sin theta I cap.
Mu sin theta I cap, right?
Yes.
That's correct now. So what is P final?
Mu cos theta
Why you? It's a change, no? New symbol.
V.
So
MV cos theta I cap.
you have to be very careful. You're not seeing the diagram and telling. You're just telling from your mind. Like there is some thought going on, and you're just saying it. Be a very alert observer. See things clearly, then say something. You are a student of science. You can't say anything without saying. Make the perfect observation, then say it.
MV cos phi
Hmm.
J cap plus
Hmm.
MV sin phi I cap.
You have got the eye in a habit of saying only without realizing, and that's why you make mistake. The day you become very focused, what is there, how to say it, how to write it, nothing can go wrong. So you want to improve or not? Yeah, tell me. Yes or no?
Yes.
How badly you want to improve?
Very.
Then bring some changes to your learning habits. Be a very good listener. Absorb the content. Rewrite the definition at home. Keep on revising in the brain. Keep on solving the derivation till you get it right, till you get confidence over the derivation. Then proceed next. If you follow these rules, you will proceed, succeed. If you want to still solve the test question of your school or coaching, nothing will happen. Let me tell you. So in your senior batch, everyone was doing the same mistake. So a girl was getting 1 mark or 2 marks in the examination, in the test. She stopped writing the test because she got scared. I said, don't write in test. You start strengthening your chapter one by one. She followed. After wasting 1 year in school, college, she followed finally. And when she followed, At the end of the course, when she was able to almost finish the syllabus, she started performing and she became the best. So if you compete yourself with today's, test or marks, you will find yourself nowhere. But the thing is, if you get it correct in terms of approach or learning, eventually you will have the reality. I mean, eventually you will perform, you will have marks, you will have everything, and you will crack the examination with you. So chapter by chapter master. Don't master, test wise. Let it be the worst rank, worst batch, worst peer group. Doesn't matter. You perform and shift the batch, shift the gear. So you have to master your topics, whatever you're learning. Understood? How
Yes.
to approach? So MV cos phi JK plus.
MV sin phi I cap.
So now you can add delta P. See, everything is in physics, nothing is difficult. You have to follow the process, think logically, follow the process, write things as per the rule, definition, and you will get the answer, sure short answer. I mean, there is no ambiguity here. So in physics, someone can score really high marks because there's no ambiguity. Once you understand, you understand. That's it. So add one chapter at a time. So how much if confident you feel in kinematics? Tell me.
Moderately.
Why moderate? Why not 100%? Because you haven't worked on it. You never try to become 100%. You try to go for that exam, this chapter, that chapter. Have you ever thought of mastering kinematics? That never came to your mind that now I'm supposed to master kinematics. You're studying kinematics, but you're not trying to master. You're not trying to, become really good with it. So tell me honestly, have you ever thought of mastering kinematics and then only moving forward?
No, sir.
So if you haven't thought about mastering, you will never master it. That's simple logic. See, for every problem, a teacher cannot be the solution. If you really want to get the solution, you have to follow someone. So if I'm saying do this way, that way, you have to strictly follow this. If you try to apply your own ideas, your own technique or strategy, I am saying you will fail miserably. So as a beginner, one should only listen. Listen with complete dedication. Follow what is being said. And don't apply your brain. Whether you have it or not, doesn't matter. Don't apply at all. Follow. Be a good follower. Clear what I'm saying?
Yes.
So if you want to master any topic, you have to devote yourself. And if you are still believing that some miracle will happen one fine day, I'll become suddenly genius and all questions will start solving one fine day, nothing will happen. I can give you a written, nothing will happen. If that approach will not change. So every chapter which is getting finished over here, you have to master it before we go to the next chapter. Kinematics you have been learning for 2 months. Even if you solve 5 questions per day, 2 months means 60 days, and this is roughly 300 questions. Have you solved 300 questions in kinematics? Tell me. Have you solved? Yes or no? Tell me.
No, sir.
So what will make you genius? If you haven't solved question, if you haven't practiced something, if you haven't mastered the derivation, what do you think will make you really good with subject? And how you can say you are wanting? I mean, you want something really badly. Aren't you contradicting your own statement? What do you mean by wanting something really bad without putting effort? Is it possible to
No.
achieve? So, because you are smart enough to understand that what is required to attain mastery in something, why don't you apply it? So the problem is application part. But still you're not ready to set yourself into that right strategy. So your brain is somewhere waiting for some miracle to happen. You want to continue the way you're learning. You do not want to bring any change to your strategy or your learning strategy. And after committing all such mistake, we expect something miracle will happen and I'll become really good with the subject. So is it going to happen? Tell me.
No.
Are you realizing this that this will never happen?
Yes.
No. If you have realized, then you would have changed by this time. You never realize this fact. You are somewhere lost in some process of your class 10th preparation, the way things happened. I mean, there is unsaid expectation that things will change automatically. You're following some, blind process. Okay, you're coming to you're coming to somewhere else, going to coaching, coming back home, and this, that. And just every day is passing without any improvement. Only days are passing. That's it. So I want to see a different version of Rigved 2.0 within 1 month. I want you to be only talking in terms of theory, definition, concept, writing a lot, reading a lot. How many pages do you read every day? Do you read any book in your life?
I used to read, I do not read. No.
Why? Are you really busy like Modi?
Some days, yes.
No, you're not busy. You have not managed the time. So how you utilize your time at coaching? What exactly you do there? So let's say you reach your classes, you reach the Allen coaching. What happens next?
Then they write on the blackboard and then I write it down.
Okay, then after this,
That's pretty much the whole class.
whole class.
Mm.
So do you try to learn there, or you only absorb yourself in writing what is written there?
No,
Like, do you feel that okay, you're listening to every word and every word is getting into your brain and you're really understanding things whichever is being said, or you're more into writing? Tell me honestly.
no, sir. I do understand the words that there's.
Okay. So you try putting effort in understanding also, right?
Yes.
And then when you come back after coaching,
Then after, when I eat and then I do some homework that they have given.
so are you trying to manage the coaching, the speed of topics being covered there, or you're trying to master the chapter? What is your present state?
I'm currently going with the coach.
Exactly. And that's why I'm saying you're not learning. You are just trying to stick to the present syllabus, isn't it?
Yes.
Every next topic coming to you, you're getting interested in that topic and somehow you're trying to understand, isn't it? And every previous topic you haven't mastered. And that is the reason that things will never improve. Because you want to be present with every topic. You have to somewhere leave it. You have to make a decision that okay, I will study chapter by chapter. I will try to master first kinematics, then laws of motion, then friction, then circummotion. Because after 6 months, when you are really master of the first 4 or 5 chapters, the rest of the physics will appear easy for you. So you have to shift the track from going along with the syllabus to learning the syllabus. If you want to see the big term benefit, so you're trying to live a short term dream and you're living the big term, long term dream for the short gain. Change it, you will see a big change in yourself. And I can tell you will be much more confident that what you are right now. Once you start mastering the chapter by chapter, one step at a time. Please do not stick to the speed. You have your own speed of learning. You may improve your speed over the time, but don't try to run along with behind the bus if you can really can't make it to the bus. Run behind something which you can achieve. Okay, what I'm saying, are getting my point?
Yes.
Why we are not improving? Do you realizing is okay that this way nothing will become concrete in your brain. No chapter, because you're always busy with new chapter, right?
Yes.
So you don't have time for the previous chapter, correct? If you're busy with every new chapter, then you don't have time for the chapter which you have covered. And if you don't have time, then how will you strengthen the chapter? What is your strategy? So somewhere you have to decide that I will now study in this way and I will strengthen my chapter one by one and I'll proceed accordingly, no matter what is my examination. I'm telling you, don't worry about examination. If you're always thinking of the examination of the coaching next day, next week, you will get in that trap forever. 70 to 80% of students they eventually leave the coaching or they just go for the sake of going because they do the same mistake. Initial chapters of whether it's physics or chemistry or math should be given as much as time as possible without worrying much. So if you're good with, if you start with kinematics, you give your time, become master of the kinematics, proceed next, then take the next chapter again, master it, and once you have mastered the first 2 chapters, the process will become inbuilt function in your brain. You can do the same thing with any chapter. So you will not find any chapter difficult in future. So please do change. These are some simple strategy that if you adapt as soon as possible, things will change for you. Okay.
Yes, sir.
So become good, better, best, genius with effort, not with just thinking. Okay. So delta P now we can write as how much?
MV cos phi j cap plus MV sin phi I cap minus
like this. Okay, there's no need to solve, but this is how you can write. Understood?
Yes, sir.
Okay. So the momentum change can be asked in a variety of ways. There is one more question. That's the last question. So you can see there is a circular track. I mean, it's a straight track with a circular bend. The radius is r, and we have a collar. A collar means some sort of cylindrical object. And this collar is thrown with the speed v. So once you throw the collar with speed v, it's a smooth track. It will go straight, and then it will negotiate the turn with the help of the circular track. So the circular track will make it move, right? Will it move on its own? So the question is, who will move the collar? This collar, moving collar. Tell me, who will move this collar?
The track.
The track actually. So this is something invisible, but it is a track which will let it move. So question is, what is the average force applied by the track in turning the direction? So you enter from A, and when you exit from B, you go in the same direction with the same speed. I mean, you go in the opposite direction with the same speed. So the question is, find average force on collar by track ACB. So how much momentum you have changed? What is the modulus of delta P? What is the changing momentum? The value wise? You entered at A and you left at B. So how much momentum change the track produced? Tell me.
M dash V minus MU. MU minus M dash V.
See, there is a problem. Rigved, you try to understand there is a problem. You never see things. Now this is the serious problem. Like you're still blind without realizing that you are blind. Tell me where I wrote the U, where I wrote the V dash. Have I written anywhere? You need to see the diagram. I said it is entering with V, coming out with V. So where is the V dash? How that V dash came to your mind? Tell me, explain that
But I did not
effect.
say V dash.
You didn't see anything. You try to answer based on some thought process which you have seen somewhere, right? The previous question, isn't it? So the ability to see the present is missing. Can you really see it and tell me? So the caller is entering at speed V and leaving also at V. So what is the change in momentum? Tell me. How much momentum the track has changed? Think about it. Any guess? Momentum is a vector. So okay, you can write in terms of vector. You can take I direction, J direction, right vector. Tell me what is delta P value. The way you want to write, you can write. Yes, Rugby, tell me. Is it very difficult to answer? And if not, then why you're not answering? So explain where you're getting stuck, what is happening, how your brain is not able to think, what kind of difficulty you face. Analyze everything.
The
Then you're learning
curve,
to conquer it. Yeah, tell me.
the curve will change the velocity, but by how much? That I'm not able to.
No, you're not supposed to think how much. You're supposed to think of initial momentum, final momentum. That's it. Before entering the track, what is the momentum?
M dash V.
No, that's M only. That's dash.
Acha, MV.
And what is the momentum after leaving the track?
MV
In the same direction?
minus MV.
Minus, because it's a changing direction. So if you think that way, what is the changing momentum then?
Minus MV minus MV
So
minus 2 MV.
the value is how much?
2 MV.
So you got the answer. No? The change in momentum is how much?
2 MV.
So you got the answer. See? The moment you become a very good observer, the moment you start thinking logically, physics will appear easy to you. And how much time you have spent with the curve track? Because the person, I mean, you can say the agent which has caused the turn of the direction is the track. So the question is how much time you spent from A to B via C. Assuming the speed remains constant, if the speed never changed over the entire journey. So how much time you spend?
R into theta by V.
No, again tell me where is theta?
If we
I mean,
take
where is theta? Come on. Why you bring something which is not there? What is the simple definition of time? Time, distance, speed relation. Tell me.
2R by V.
Time, distance, speed. How difficult is to see the distance? You go from A to B via which path? You go directly A to B or through the track.
Through the track.
So how much distance you traveled? Distance, 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 beta, distance, not displacement. What is the actual path length from A to B to via C? Tell me.
Pi into R.
So you got the distance right?
Hmm.
And what is your speed?
V.
So how much is time?
Pi R by V.
Simple. See, you're getting all answer, but I don't know why you're not thinking. Because you haven't developed the habit of thinking. And that's why I'm saying you spend some time, think about problem, think about concept, spend some time, solve question, realize question, then move ahead. Why you are trying to be in hurry of solving everything? See, today I have spent a lot of time in explaining how to study. Don't expect that I will be saying the same. If you're not changing every time I'm saying something, you're not changing. I may try once or twice, but eventually I will leave. Then I will leave to your fate. So this is very clear. As a teacher, we do try to change the learning pattern, the learning paradigm. I mean, there are many wrong things that students are addicted to. They're trapped in some wrong addiction, which they never realize. It's like a blind way of learning. You do something blindly, you don't realize whatever is happening. You don't see the diagram, you don't listen to the concept. Then things goes wrong in many ways. I have put effort to let you know that this is not the right way. The right way I have discussed. Now, whether in future you want to follow the right way is up to you. You follow it, I will keep on helping you. You stop following it, do not expect anything from it. Okay, I think I am clear.
Yes, sir.
So, what
Yes.
is the average force by definition?
Delta V by delta T.
So, change in momentum is how much,
2 mv.
and how much time you have taken?
Pi R by V.
So, how much answer you got?
2 mv square by pi R.
That 2 mv square by
Pi R.
simple. If you always proceed with logic, the logic which you have learned, and physics never demands something beyond logic. That's the beauty of physics. You're not supposed to know any fact or formula. If you know the definition, you have to apply it without worrying much. Okay, I hope this is clear.
Yes.
And see, it is not me, you are only solving. It's not difficult. If it is really difficult, then no one can solve. Okay. So you have solved with a simple definition of Newton's second law. These all question that we solved, we just simply use the Newton's second law. So as a learner, we need to think about the definition. What is second law? How to use it. So we learn two things. First, you know something. This is like fact. So Newton's law is given to you as a definition. Once you understand the definition, then as a teacher, my role is to give you examples to understand the application. Once I have given the examples to understand the application, the next part comes is practice to get your own concrete ideas there. So these are three steps actually. My job is to explain definition and give examples to make the ideas concrete. The next step is for the student to practice till you realize. And once you realize the idea concept, you can leave and go to the next topic. Follow this pattern if you want to master it. Else, you know what you can achieve through the way you're doing things. Correct? So the next part is the Newton's second law again. Newton's various interpretation. So what are the various interpretations? So the definition gave you one formula. And what was that? F equals to
P by dt.
dp vector by dt, right?
Yes.
From the definition of momentum P, we can write as
J, J into
no, P equals to what is the definition of momentum?
mass into velocity.
M into
V vector.
V vector. So how many variables we have? How many parameters we have in the definition of momentum? M and V. Correct? P equals
Yes.
to M into V. So how to differentiate P? D by dt of mv. So as per the rule of differentiation, which rule we need to use here to differentiate mv together? Which rule? Tell me.
Multiplication.
So the next question is, do you know that rule?
Derivation of m plus d v by dt.
Is this the rule? Something else?
Now that is the constant rule.
No, if m is not constant, then
M d by dt plus v dm by dt.
very good. So is it necessary that in the entire physics m is always constant?
No.
Can you give me some example where it is not constant? Some example? Give me one example in which the mass is not constant.
Mass will be constant.
Is it necessary? In laws of motion, we define something called system, right?
Yes.
So in the formula, when you write a D, I mean, when you differentiate mass, the M represents the mass for system. So is it necessary that a system considered for observation must have constant mass? Like what is forcing you to believe that mass cannot change? Let's say, take a simple example. Let's say a person, I mean, there is a street vendor selling some fruits carrying over his head in a bug basket. And as he is running, the fruits are, let's say, spilling out. So if I consider the entire mass of the food basket and the man, is the mass constant or variable?
Variable.
Imagine you are in some place like Canada or Antarctica where there is a constant snowfall. And then you are carrying again a basket on your head. As you move along, the snowfall will fall in the basket. So your mass will remain constant or will change.
It will change.
So can we have a situation in which mass of a system which is under motion may change?
Yes.
And the big example is all the rocket launch. In rocket, almost 3/4 of the mass is only fuel. The rocket is a small part. The rest is only fuel. And at a different stage of the journey, they consume the fuel and they throw the fuel tank. So you must have seen in a rocket there are many side rockets attached, right?
Yes.
Those are fuel tank actually. So they consume the fuel tank, they throw it. The rocket is only the cockpit, the topmost. That part is only rocket in which the satellite is actually standing. The rest is used for fuel actually. So as the rocket will go upward, it will burn out the fuel. So mass will change or remain same.
Change.
So now there is a reason that everything in physics is not having the constant mass. Of course, this chapter which we are going to study will deal with constant mass system, but we mentally prepare that though this chapter will have the constant mass system, but it is not the necessary. So as we go to the next chapter, I mean next means at the end of mechanics we have central mass chapter. There we have to study the variable mass systems. Right now we are going to study the constant mass system. But in general, when we write a law, then law is for all kind of system, right? So Newton's law, is there anything Newton said that okay, no, my law is only for constant mass, or Newton's law can also be applied for variable mass? Tell me,
Variable too.
correct?
Yes.
So therefore, these various interpretation must be understood. So of course, you will come across this again in the chapter of center of mass, collision, or called system of particles, but the definition remains same. So F external, when you write like dp by dt, this is definitely the Newton's second law. If you write d by dt of mv, this is definitely Newton's second law. But if you write m dv by dt, not the second term, this is incorrect. Because you're writing the law for the general system. You haven't written as a heading that this law is I'm writing for the constant mass system. If you mention that this is constant mass system, then this becomes correct. But do we write law for one particular case or in general case?
In general.
And that is why if you want to write this further, you have to write this way. You can write m dv by dt plus v dm by dt. A variable mass system also creates a force. So the external force is m dv by dt. What is the definition of a rate of change of velocity is called?
Acceleration.
So this is called ma plus v dm by dt. Now, a body acted upon by any number of forces will accelerate in one particular direction, or it can accelerate in two directions at the same time.
It can accelerate in many directions.
It can accelerate only in one particular direction, isn't it? So acceleration always represents the one single direction. Correct?
Yes.
Acceleration means actually the tendency in which you are going to move further. So one object cannot have two acceleration. It must have only one acceleration. So that's why the actual motion depends on net force. This is called net force. So we have a name, net force. So net force is ma, but Newton's second law is not ma. In your high school, what you studied, that Newton's second law is F equals to ma, isn't it?
Yes.
Which is now wrong. So you cannot use the same definition today. So F external is actually Newton's second law, which is sum of net force and force due to the change of mass which we call thrust force. But for system that we are going to study, the thrust will go away, and therefore the Newton's second law and the net force becomes equal. So these are the various ways of writing Newton's second law. Now you can make a heading, and what you can write? For constant mass system. What you can write for constant mass system?
F external equals ma.
dm by dt equals to 0, correct?
Yes.
So this equation implies, one implies F external is F net, and since net force we write as mass into acceleration. See, net force is mass into acceleration, and for constant mass system, external is also net force. So all are same. So F external is same as net, and that is equals to m. So whether you write this equation or you write this equation doesn't matter because of this condition. So when you studied that laws of motion in class 9th, that time the variable mass system was not considered at all. And so you were told that the Newton's second law is F equals to ma. Now in JEE, if you write Newton's second law F equals to ma, it's the wrong answer. So how to write Newton's second law? This way, or this way. These all are the valid way of writing. What is not Newton's second law? So always remember, is if someone will ask you, is this Newton's second law? Is this Newton's second law? What is the answer?
No.
So now you need to remember this fact. Okay. I hope this is clear.
Yes, sir.
Yes, sir.
So we'll discuss about the third law in the next lecture. Today I just try to keep it short because you are absent. So next lecture will be the real laws of motion, where you will see the pulley, tension, normal, and all those things. Okay. So I think I have shared the notes. Yes or no?
Yes, sir.
Okay. So now you can start reading the notes. It will save your time. Also, it will make you understand things really fast. So don't waste your time. Before the next lecture, make sure that you have read a lot. Also, make a habit of that before every lecture, you have a textbook like